Hello everyone, welcome to the YouTube channel of Lightway Research and Technology Center. In this video, I will show you how to estimate quantile regression model in EViews. Here are what we are going to cover in this particular video. Firstly, we are going to look at the definition of quantile regression. Next, we are going to look at the reasons for performing quantile regression analysis. Then I'll provide the summary of the reasons, and next to that I will show you how to specify quantile regression model, and the last part is how to estimate quantile regression model in EViews. In our next video, I will show you how to interpret quantile regression results. Also, I will demonstrate how to perform post-estimation test and how to interpret the post-estimation test results. Before we proceed, please, if you are just coming across our channel for the first time, kindly click on the subscribe button below to be part of this great community. Also turn on your notification bell so that you can be informed when we release new videos. We also appreciate it if you can like our video and share with your friends as well as your family members. Now let us look at the definition of quantile regression. But before we take a look at the definition, we need to understand classical least square model. Please take note that the classical least square model it shows how independent variable affects the conditional mean of an outcome or a dependent variable. So classical least square is used to estimate the conditional mean of a dependent variable. Quantile regression is an extension of the classical least squares that estimates the conditional quantiles of a dependent variable. While classical least square focus on the conditional mean of a dependent variable, quantile regression estimates the conditional quantiles of a dependent variable, and this of course make it less influenced by extreme observations. Quantile regression is a powerful tool for analyzing relationship between variables, particularly when there are concerns about the assumptions of the traditional regression techniques. Also, it is used when a more comprehensive understanding of the conditional distribution of the outcome variable, that is the dependent variable, is desired. The interpretation of the classical least square results is that a 1% increase in the dependent variable leads to certain percent increase in the dependent variable on average. But for quantile regression, there is need for us to indicate the quantile at which that particular relationship occurs. For instance, if you estimate quantile regression and you make use of 30 percentile or 0.3 quantile, in your interpretation you must indicate that particular quantile. Let us assume you have your results for 0.5 quantile, which is the median of 50% percentile. Then when you are interpreting it, you need to say that a percentage increase in X leads to certain percentage increase in the dependent variable at 0.5 quantile. So don't forget, this is very important piece. When we get to the interpretation of quantile regression results, I will discuss it more. Now let us look at the reasons for performing quantile regression. The first is that it is robust to outliers. Second, it is robust to heteroscedasticity. And the third is that it can be used when the distribution of your data is not normal. So now let us look at the first point, which is robustness to outliers. OLS regression is sensitive to outliers because it seeks to minimize the sum of square residuals. And also take note, OLS regression estimates the conditional mean, so it may not be able to capture other observations that are far from the mean. But quantile regression estimates the conditional contours of a dependent variable. As a result of this, it's able to capture the spread of the observation, and this makes it to be less influenced by extreme observations. Let me put it this way: quantile regression can be estimated for 0.5 quantile, 0.2 quantile, 0.3 quantile, 0.7 quantile, 0.9 quantile, and so on and so forth. So that makes it suitable for a situation whereby the observation spread where there are outliers, because it's certainly going to capture 90% if not all. So quantile regression is robust to outlier. The second reason is that it is robust to heteroscedasticity. OLS regression assumes constant error variance across all levels of predictors. But this particular quantile regression does not have that particular assumptions, and in the real world situation, these assumptions may not hold. So when you notice that there is a problem with your heteroscedasticity results, then the best methods to use is quantile regression, because it does not make the assumption of constant error variance. And the third one is non-normality, and this is a situation whereby the residuals of ordinary least square regression are not normally distributed. When your data are not normally distributed, so when you notice that the probability value of your normality test is less than 5%, then the best methods to use is quantile regression, because it does not rely on the assumption of normality, and that makes it to be more robust to deviation from normality. So quantile regression enables researchers or analysts to study the impact of dependent variables on different quantile or percentiles of dependent variable. So it provides a complete picture. Why do I say complete picture? It is because it makes it possible for researchers to capture the relationship at different quantile, 0.2 quantile, 0.5 quantile, 0.7 quantile, and so on and so forth. So it provides a complete picture of the relationship between a dependent and independent variable, because it analyzes the distribution rather than the average. In other words, it makes it possible for researchers to determine the heterogeneous effects of the independent variable on a dependent variable at different quantiles. Now, let me quickly give you the summary of the reasons for performing quantile regression. The first is that when you take a look at your histogram, which shows the normality of your data, and you notice that the data is not normally distributed, that is, the probability is less than 0.05, which is 5%, then there is a problem with that particular data, and the best method is quantile regression. Also, when you check the serial correlation and you notice that the probability value of the F statistics is less than 5%, then you make use of quantile regression. In another case, you may notice that the result of the heteroscedasticity test is also less than 5%, then the best or the most suitable techniques for that particular data is quantile regression. In other words, when you have a problem with any of this particular test, histogram, serial correlation or heteroscedasticity test, then you should use a quantile regression model. Now let us quickly take a look at how to specify a quantile regression model. Here I have the model, and the first is Q subscriptile. If we delete this Q subscriptile and this tal, and this, then we have a classical linear regression model. That is when we have y subscript t equals to this intercept, this is intercept, and this is the parameter of the independent variable. X is the independent variable, while this is the error term. So when we have a model without this tal, this, and this, then we can say the model is a classical linear regression model. What makes this particular model a quantile regression model is this tal. So when you want to specify a quantile regression model, you should add this tal to it, and this tal is the one that indicates the quantile. So you can change the tal from between 0 and 1. So the tal is less than 1 but greater than 0. So it must not be 0 and it must not be 1. So it is between, the value should fall between 0 and 1. Now, where this qt is quantile and y is the dependent variable at time t, take note, when you have this particular t, it shows that the model is a time series model. The conditional quantile for which equation is being estimated is denoted by this tal, and the value should range from 0 and 1. So it should be less than 1 but greater than 0. The unknown intercept, this is the unknown intercept at tal, is denoted by this, while the unknown parameter, you will certainly have the value of this intercept and parameter after the estimation. The unknown parameter which is associated with this particular tal, that is maybe 0.4 quantile or 0.2 quantile or 0.5, which is the median quantile, is denoted by this beta subscriptile. Now the x is the independent variable at time t, while this e subscriptile is the error time. So, but what I want you to take note here is this tal. So you must ensure that you add it to your model, because it shows that the model is a quantile regression. And when we get to the estimation of quantile regression model, I will show you how to vary the value of the tal from 0 and 1. Please take note that quantile regression is most suitable for large sample data. When you want to use a quantile regression data, please make sure that you increase the sample size of your data. This is because it enables you to estimate more quantiles. What I'm trying to say is that when you have a small sample size, you may not be able to estimate more than 5 quantiles. But when you have a large sample size, like 100 observations, 50 observations for upward, you will be able to estimate the regression model for like 10 plus quantiles. So when you want to use a quantile regression model, ensure that your sample size is large enough. And another thing I want you to take note is that you can use the tal for robustness check. For instance, if your baseline model is 0.5 quantile, which is the median, then you can also estimate the model for 0.4 quantile, then 0.6 quantile, Of course, you can estimate more, maybe 0.7 quantile, which is 70 percentile or 90 percentile. So instead of using the different techniques of analysis to authenticate your results, you can just estimate for different quantile, then you compare the results. If the results are similar, then you can conclude that your result is robust enough. In our next video, I will show you how to interpret quantile regression. But now let us go to EViews so that I can show you how to estimate quantile regression model. Here we have the dependent variable, which is mortality rate, MMR, and we have the independent variables, which are government expenditure on health and urbanization. The first thing you need to do, the first pretest is to perform descriptive analysis. So when you want to perform descriptive analysis, you select the dependent variable and the independent variable. This particular analysis will show us the probability the probability value of the Jagubera statistics for each of the variables. So it will tell us whether the data are normally distributed or not. So now to perform descriptive statistics, you highlight the variables, then you go to group statistics, click on descriptive statistics, common sample data, since the observation are the same across the variables. Then we have this particular window with the names of the variables. Here is our descriptive statistics. What we are interested in is the probability value of this particular JB statistics. And if you look at the probability value of the mortality rate, you will notice that it is less than 0.05. It is less than 5%. So that tells us that mortality rate is not normally distributed. Let's look at government expenditure as well. The probability value of the Jagubera is also less than 5%. So that shows that this particular variable too, the data is not normally distributed, but urbanization is normally distributed. Why? Because the probability value is greater than 5%. The probability value exceeds 5%. This is 35%. So based on these particular results, we can make use of Quantile regression model. Classical linear regression model is not suitable for this particular analysis because one of the assumptions of the classical linear regression has been violated, which is what? Normality. You can also justify the use of Quantile regression analysis by conducting heteroscedasticity test as well as serial correlation test. So to do that, you first need to estimate an ordinary least square model. Then you just right click, open as equation. Here the method is already least square, so what you just need to do is to click on this OK. Then you have your least square results. You can see the method least squares. To check for the serial correlation results, you go to View, then you select Residual Diagnostics, then select Serial Correlation LM Test. This is the results of the serial correlation LM test, and you can see that the probability is less than 5%, which is the confessional level. So this is also a problem, and it violates the assumption of the least square method. So based on this, you can also make use of Quantile regression. Another test that you can also conduct is heteroscedasticity test. So you just go to view, you select residual diagnostics, then from there you move to heteroscedasticity test. Click on this, then you can just select Brief-Vaughan-Godfrey test, then you click OK. Now check the probability value of F statistics. You can see that it is also what? Less than 5%. And don't forget, when I was summarizing the reasons here, I made it clear that when the LM, which is the serial correlation, is less than 5%, and or when the heteroscedasticity test result is less than 5%. So it is clear based on this that classical linear regression model is not suitable for this particular analysis. Of course, you can also conduct the normality test. You go to view, residual diagnostics, then you select histogram normality test. You have this result. Well, this is greater than, the probability is greater than 5%, but this shows the result for the all the data, that is all the variables. The residual here is the residual for the 3 variables. But what you need to take note is that the result of the descriptive statistics clearly show that mortality rates as well as government expenditure on health are not what? Normally distributed. So we can proceed with the use of quantile regression for this particular analysis. Now, to conduct a quantile regression analysis, what you need to do first is to select your dependent variable followed by the independent variable, similar to that of OLS. Then you right click, you open as equation. Here, instead of least square, you need to select quantile regression. So just check for the quantile regression. Here is it, quantile regression. Then you select quantile regression. You can see that the interface has changed, and one key thing that makes this particular quantile regression unique is this quantile, which is tau in that part in the model that we specified or that I explained the other time. So here, if you estimate for this, if you make use of 0.5, then you have your results for the median. But the point is that you can vary the value here between 0.1 and 0.99. You understand what I'm saying? So you can first estimate for 0.1, then you do for 0.2, you do for 0.3. Depends on what's on the quantile or the percentile you want to make use of. So let us start with 0.5, which is the median. So here you just indicate 0.5, but don't forget, quantile regression will give you the best results, or you'll be able to estimate more quantiles when you have a large sample size. So let us start with 0.5. Then you just click OK. This is the dependent variable followed by the independent variables. The C here is the constant, which is the intercept, and the tau in the model is this. So you are going to determine it yourself. So now let's click on OK. This is the baseline result. I call it baseline result because it's the result for the median. Of course, your own baseline result may be 0.2 quantiles, but in this case, the 0.5 quantiles gives us the the baseline model. So from here we can estimate for other quantiles. You can just twist this and get results for other quantiles from here. And if you look at it, we have government expenditure on health, urbanization. I will explain the interpretation in my next video. So let me just show you how to estimate the regression for different quantiles here. Now if you want to get for like 10 quantiles or 5 quantiles, let us start with 5 quantiles. The first thing you need to do, please take note that the dependent variable is what? Mortality rate, MMR, and the method here you can say quantile regression, not least square. And the tau 0.5 has changed to median because the value is 0.5, not 0.2. If it is 0.2, it will indicate it, but 0.5 is the median for this particular quantile regression model. So that's why it gives us median instead of 0.5. Now to estimate or to get result for about 10 quantiles and so on, or 5 quantiles, you need to go to view. So once you click on view, you select quantile process. Then from quantile process, you will select process coefficients. So once you click on this, we have this main window. Just retain these settings. Now the output is depend on what you want. You can choose to have your outputs in a graphical form. Also you can choose to have it in a table. Then let us start with the tabular form, and here this 10 shows that it tells us that okay, this particular software will give us results of 10 quantiles or for 10 quantiles. Now let us start with 5 quantiles. So what you just need to do is to change the 10 to 5, then you click OK. Now if you count this, you will see that we have 5 quantiles. 1, 2, 3, 4, 5. So this is the result, and you can see estimated equation quantile is what? 0.5, and this is the result for 0.5. If you check, it is not different from the baseline result, and the number of process quantile is what? 5. Now if you want to estimate like 10 quantiles, then you go back to view, quantile process, then process coefficient. So you just maintain this 10, then you click OK. Once you click OK, the quantile will increase towards the 10. Now we have 10 quantiles. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is now up to 10 quantiles. Yeah, this is 10 quantiles, but you can see number of quantile process is 10. Okay, because the last one will give us what? 1. Don't forget it starts from 0. So if you want to get the 10th quantile now, based on this interval, it will be 1. That's why it is eliminated. And you should take note that the tau should be what? Less than 1 or greater than 0. But if we change this to 12 quantiles now, the interval will differ and we'll be able to get the result. So let us go back and change this to 12. We want 12 quantiles, and you click OK. Now let us count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Okay, well, I think that's the standard. So now we have for 12 quantiles, which is, and these are the quantiles. The first one is this, second one is this, third one is up to the last quantile. So now all these quantiles shows the relationship between what? Government expenditure on health and mortality rate, while these ones shows the relationship between urbanizations and mortality rate. Of course, if you want to estimate, or if you want to increase the quantiles, what you just need to do is to go back and increase it to, let's say, 13. Let us check if 13 will work. Okay, now you can see our sample size is not large enough, so it is not possible to estimate 13 quantiles. But in case you have a specific quantile that you want to estimate, you may not need to go through the quantile process. You can just come back after estimating the first one. Let's assume the first one is 0.2 quantile. You can just estimate 0.2 quantile, then you click OK. You copy and paste your results somewhere, then you go back. Let's assume the next one you want to estimate is 0.4 quantile. Then you change it to 0.4 or 40 percentile. Then you click OK. So you do it one after the other. Then you just copy your results and summarize everything in one table at the end of the day. So that is how to estimate quantile regression model using the tabular form or the table approach. Now let me show you how to make use of the graphical approach. So once you have your results, what you just need to do is to go back to view, quantile process coefficient. So instead of table here, you will choose what? Graph. And when you select graph, you will notice that the coefficient, the confidence interval size is by default 95, is 95. That is 95, 0.95. But if you want to make use of another confidence interval, what you just need to do is to change this to your desired confidence interval. But in this particular analysis, we are going to maintain 0.95 confidence interval. So you just retain that. Then the next thing you need to take a look is your quantiles. How many quantiles do you want to estimate? If it is 10, you retain it. If it is 5, you make that particular adjustment. You make that particular adjustment. Next is to click on OK. So once you click on OK, you have the graph. The two red lines, the one at the top and the one at the bottom, are the confidence interval. So this is 95, 95, and this particular blue line shows the estimates at each quantile. 0.1 quantile, 0.2 quantile, this is the estimate, and 0.3. so this particular one shows the estimate, and you can see that it is not stable. In my next video, I will show you how to interpret this particular results. Also, you have the graph for government expenditure on it. Next to it is urbanization, and the last one is constant. So with this, we have come to the end of this particular video. Please, if you are just coming across our channel for the first time, kindly subscribe by clicking the subscribe button below. This is a great community and we will certainly enjoy it. Also, you can turn on your notification bell so that you can be informed automatically when we release new video. Please also give us a thumb up, like our video, share with your friends and your colleagues, and to all our subscribers, we'll thank you for what you have been doing for us.